G'day guys, how's it going? So in this video, we're going to look at vectors a little bit more, and now we're going to look at how we can add things to lists, how we can process them, how we can remove things from lists, or vectors in this case, and just an overall understanding of how vectors can be used in Rust, okay? Now just keep in mind that this is only going to be a subset of what a vector can do. There are other methods and things like that that can be called that do other things, but this is pretty much a reasonable list of the things that you'll do most of the time. Okay. So the first thing I'm going to do is I'm going to show you how you could use a vector to build a very simple stack data structure. So what's a stack? Well, it's similar to like the stacks we've been talking about. We push something into the list and then we pop it off on the top, right? So the way that we do that with vectors is like this. So let's create a mutable vector called, let's say, stack number list, like so. And I'm just going to set it to a vector of I32. And I'll set it to an empty list, right, like so. Cool. Then in order to push something onto a stack, say, in this case, a vector, we can actually use the push method. So we can do something like stack number list dot push, right? And we can say push number 1 in. So what will happen here is this will actually push the number 1 to the end of the list, which can be simulated as on top of the stack, okay? If we flip it from horizontal to vertical, that's what it can be perceived as, right? So let's just quickly print this list. So I've got a method up above that allows me to print the list out without me having to concern myself every time with having to write the same code. So if I do this and I run it, you'll see that we print out just the number 1, right? Because that's the only item in the stack. If I now come through and we push a few more on, so let's push 5 on, for example, 2, 3, 4, and 5, and we run this. Now we've got a stack that starts with, ends with 1, and then it's 2, 3, 4, 5. So basically the latest one gets pushed onto the end of the list, right? So the latest one in this case is 5. Now, if we want to pop off the stack, well, there's a special function called pop, right? So first, let's just quickly illustrate that pop is not a simple method. It's actually one that uses an option. So if I just go let, I don't know, let's go top stack number equal stack number list dot pop, like so. What this is going to return an option, right? Now, the reason why it returns an option is because pop will return none if it's an empty list, okay? But in this case, it's not an empty list, so it's going to return something. It's going to return a sum, which is the last value, right? So I'm going to convert this to an if expression, which is what we saw in the previous video. So we're going to go if let top stack number, and then we're just going to handle, in this case, if it's a sum of top stack number. And then basically I can do something like print line. Whoops, I always forget the exclamation mark. I have popped the value top stack number off the top of the stack. Now keep in mind, this is just a list, right? But the way that we've done it is that we've pushed on the end and we're popping off the end, which is the same way in a stack as pushing onto the top of the stack and then popping off the top of the stack. So the value you expect here is 5, right? So let's just save and run it. And there we go. I popped off the value 5 off the top of the stack. So 5 was the last one in. It's the first one out. Cool. Which is what a stack is like. It's a last in, first out approach. We can do it again. So we can basically copy this code and we can just rename it to, let's say, second top stack number, just to be discreet here. We don't technically need to do that, but we're going to do it anyway, just to distinguish. And now you can see 4 was popped off the stack and it's left with 1, 2, and 3. Cool. So that is how we could somewhat simulate a stack data structure using vectors, right? Now we can also do what's called a queue. So a queue is a first in, first out approach. So when you push something into it, you then get it out the other side. That's the first one to come out. So we can do that by, let's just remove all this. And we'll start again with a mutable vector, which we'll call Q number list. Make it a vector of I32, like so. And again, it'll be an empty vector. And then we can do pretty similar to what we did before. So instead of calling push this time, which pushes on the end of the list, we're going to push at the front. And the way we can do that is to go insert at the 0 position, the number we want. So in this case, we'll say 1, right? And then I can basically print that list out again, just to prove that it's working as intended, right? So let's just quickly check that and see if it's actually printing out 1, and it does. Don't worry too much about the comma. It's just because this function doesn't cater for the last item. I don't really care too much about that, but basically if we add a few more on, so remember all these are going to be inserted to the front, right, of the list. So 2 will go in front of 1, then 3 will go in front of 2, then 4 will go in front of 3, and 5 in front of 4, right? So now if I run this, now we've got a list where 1 is on the end. Cool. Now to simulate a queue where we have to get the first one that went in and make it the first one out, we can do the same as before, right? We can introduce that same if logic with the pop. So we can go if let sum, and we'll go first queue number is equal to queue number list dot pop. And then we can print line, I have removed the value first queue number, from the queue. Cool. And then we can just print the number list straight after that. So let's print it before and after. So let's print it here and here. I'll give it a run. And now you can see the list before the pop took place was 54321. Now it's just 5432, right? So we've removed that first item as we would in a queue. We're processing the first item that went into the queue, and then it was the first one to come out. Cool. So there are 2 data structures you can implement with vectors, okay? Now, just to be complete, let's just look at a few more methods and functions that we have on a vector so that you have a better understanding of how to process items in vectors. So let's go with the approach of, let's say, sorting, right? Something you might want to do regularly. So because we're using a numbered list, so we'll go mute again, random numbers equals vector. And this time, this time we'll start with some numbers. So we'll go 6, 4, let's say 3, 7, let's say 9, 1, we'll say another 3, 2, 8, and maybe another 3, right? So we've got some duplicates in there. So let's just print this out just to make sure it's working. Cool. So just make sure this is fully working. It's going to complain about the mutable. That's all right. So there's our number list, right? So if we now go through the process of, let's sort. So to do that, we just can go sort. And because we're using numbers, it knows to sort them based on order of number, right? So the first one will be 1, then 2, then 3, and so on and so forth. So let's just quickly run that. And now we see a sorted order from 1 through to 9, right? Now you can do all other kinds of sorts. I won't show that in this video. You can look that up yourself. And there'll be much more complicated sorting that we'll look at later when we start looking at things like objects and things of that nature. But for now, just understand there is a sort function on a vector, And if you do it with just numbers, it'll sort it in order of, increasing value. Cool. What you can also do is when you have sorted it like this, you can remove duplicates pretty easily. And the way we can do that is to use another function called DEDUP. So delete duplicate is the way to remember it. And if I save and run this now you'll see it'll just give us 1 to 9 and all the 3s were removed. Whereas before we ran that dedupe method, you will see that we had 3 lots of 3 in there. Cool. So that's another thing you can do with vectors. What else can you do? You can get the first value easily without using indexing by just calling dot first and dot last. So that looks like this. So if I go, let's remove all of this and remove all this as well. So if I go if let sum, and we'll go first number equals sorted list, random numbers dot first. Right. If I do this, then I can actually print out the first number, right? So first number is in list is first number, right? And that's a safe way of checking that there's an item actually in the array and you're getting the first one. Whereas if you were to do it the old style index way, you would do something like random numbers 0, and if the list was empty, it would crash, right? So this allows us to try and safely get the first number if it exists and do something. Otherwise, it won't process anything because it's empty, okay? You can do the same for the last as well. So let's just quickly see that. So we can go last number, and last number. And that's just by calling dot last. And in fact, I can remove mute for a second because I'm just getting values from it. And there we go. It gives us the first number, which is 6, and the last number, which is 3. Cool. What else can we do? We can also insert numbers at specific spots in the list. So not just at the front and at the back. So we can do something like this, where, let me just print the list again. So we can do something like random numbers dot insert. Instead of just 0, I could pick anywhere in the list and basically pass a number, say 20. And if I run that, you'll see that 20 is in the 4th or index 4 position, so the 5th position in the list, right? So you can do that. We can also remove items, obviously. So if I go through the process of, let's do something like let number removed equals random numbers dot remove at index 4. Now keep in mind, these aren't returning options, they're just returning numbers. So they're not safe, but they're just there. So you understand that they're there. So this one returns the number at the 4th position and removes it from the list. So I can print out here number, removed was number removed. Cool. And if I run this, well, you're going to see that the number at the 4th position, which is 9, right, that has been removed, right? You don't see 9 in this list, and it says above it, number removed was 9. Cool. Now, if you want to remove more than one number at a given spot, so maybe you want to remove, say, the first 2 numbers in this list, you can do the following. So you can go let's say removed items, and we can say splice. And splice takes a range. So I can say from index 0 up until index 2, but not including index 2. All right, so it's a typical range operator that you would see in a for loop that we've seen in the past. Same deal here. And then we have to give it a replacement. So we're not going to replace it with anything. This is how we can remove multiple values from a vector without adding anything in its place. So we can do that, and then we can do, like, say, for removed item in removed lists, or removed items, sorry. And I can just print out, say, removed item, like so. And I can also remove this line down here. And I'll just add, for the fun of it, just a print line there, just to make it separate on each line. So if I run this, oh, I got an error. I forgot the exclamation mark. So now you'll see it gives us 6 and 4. I forgot to add the comment space here. So it should give us 6 and 4, which are the first two values of the list, right? And then the remaining list is 3, 7, 9, 1, 3, 2, 8, 3, right? Which is the rest of those numbers there. So that's how you can remove multiple items from a list given a range of indexes. So I could easily go from this to, say, 7, right? And if I do that, you're pretty much going to get most of them, and then there's only going to be 3 left over. Cool? So that's how you can do that. What else can we do? I'm just trying to think. Well, obviously the other thing we can do is we can replace things. So say I want to get the first two values. I want to remove those, but I want to replace them with 2 different numbers. So let's say instead of 6 and 4, I want it to be 10 and 11. Right? If I do that, and we'll just basically for now not worry about the items that have returned. We'll just splice it directly like that. So we just get the list. And now you can see 10 and 11 is there. If I do remember the list and I put it all back how it was, it's going to show us that it's got 6 and 4. And then the list of 10 and 11, which is in its place. Cool. So there's another thing you can do. Probably the last thing that I'll show in this video is clearing a list. So this is pretty straightforward. So I can go random numbers dot clear like so. But what I can also do is I can check for if the list is actually empty, right? I can say let list is empty and make it equal to random numbers dot is empty. Cool. And then I can clear it, and then I can print out that value. So let's go print line list is empty. List is empty. Cool. And then I'll just copy that underneath here. And just to be complete, let's print the list out after it. And then I'll just reassign it after it's been cleared. And you can redefine it like this. Don't know if I've shown this before, but you can do that. It wouldn't be my first choice to do that, but I'm just being quick. So if I do all this, you'll see list is empty is false at first because that's the list. Then we cleared it. Now we check to see if it's empty, which will be true. Then it says true. And then obviously when it tries to print the list, it prints nothing because there's nothing to print. Cool. So they are most of the main methods that you'll use with vectors. There will be some that we'll introduce later on in regards to other things that we need to know. But that's enough we need for now to get back on track for memory, which is basically talking about strings and slices. But in the next video, we're going to focus on slices. So I'll see you all then.